All right, these are the notes for Pre-Calc Appendix A.2. Our objectives today, I will be able to add, subtract, and multiply polynomials. I'll be able to find special products of polynomials and factor them either using those special products, our trinomial methods, factor by grouping, and then finally evaluate using function notation and substitution. All right, so A.2 is polynomials and factoring, adding, subtracting, and multiplying polynomials. A polynomial in X is any expression that can be written in the form a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, etc., all the way down to a to the 0, where n is a non-negative integer and a sub n is not 0. All of these are called our coefficients, those numbers that are in front of a variable. All right, the degree of the polynomial is the highest power or exponent. So in this case, that is our n value. That would be our degree. A sub n is called the leading coefficient. When the polynomial is in standard form. In standard form means that a polynomial is written with the powers of x in descending order. All right, so highest power down to lowest. A monomial, binomial, and trinomial. Monomial is a polynomial with one term, binomial has two terms, and trinomial has three terms. To add or subtract polynomials, you can combine or add or subtract like terms. And remember, to be like terms, they must be the same variable raised to the same power. All right, so first example. In this case, we are adding two polynomials. Both have a highest degree of 3. So we're looking for like terms. We have some x cubes here and here. We can add those together to get 3x cubed. Then we look for our squares. We have negative 3x squared and a positive 2x squared. We're going to have negative 1x squared. Then if we look at our x's, we have 4x and negative 5x. We'd have negative 1x. And finally, our constants, we have a negative 1 and a positive 3. So we end up with a positive 2. Where we have to be very careful is when we have subtraction here, because this subtraction applies to every single piece in the parenthesis following it. So let's rewrite this. We have 4x squared, we have 3x, and a negative 4. And then we have negative 2x cubed, negative x squared, positive x, and negative 2. And notice that our highest power is right here. This would come first when we write this in standard form. So we have negative 2x cubed. Then we can look for our squares. We have 4x squared and negative 1x squared. So we're going to have 3x squareds. Our x's, we have a 3x and an x. So we have 4 x's. And then our constants, we have a negative 4 and a negative 2. So we will have a total of negative 6. All right. Looking at expanding the product of two polynomials. Typically, we look at this and think of foiling. Foiling is just an extended distributive property. So in our first example here, it's showing that 3x gets multiplied to both of those pieces. That's the F and O part of foiling. All right, so in both cases, we're going to get the same answer. 3x times 4x would be 12x squared. And 3x times negative 5 would be negative 15x. All right, same thing we get here. 12x squared and negative 15x. Then with distributing, they're showing that this 2 has to get multiplied to both pieces. So again, we distribute, and we're going to have 8x minus 10. Same thing here, that would be the I and the L part of FOILing. Insides, 8x, and then last, negative 10. And then we simply combine any like terms, which would include these. So we have 12x squared minus 7x minus 10. And again, we get the same answer for both pieces. So it doesn't matter to me if you think of it as FOILing or just extending that distributive property. All right, example 2. We are multiplying polynomials. This time we have larger polynomials. You can use that same expanding the distributive property, but we're going to look at it in terms of vertical form, which means we're going to take our two polynomials. So we've got x squared minus 4x plus 3 and put it here. And then we have x squared plus 4x plus 5 and write it there. So we arrange them in standard form, one on top of the other. Align the terms vertically. So as we multiply each term, we're going to make sure that we line them up as we go. All right, so we have x squared. We're going to take that times each of these. So x squared times x squared would be x to the 4th. X squared times negative 4x is negative 4x cubed. And x squared times 3 is 3x squared. Then we're going to go through and do the same thing with the 4x. Multiply it to each piece. 4x times x squared is 4x cubed. We're going to write that underneath our other x cubed so we have like terms lined up. 4x times negative 4x is negative 16x squared, and 4x times 3 is 12x. And finally, multiplying 5 to each term. 5 times x squared, I'm going to put them under my other x squareds. 5 times negative 4x is negative 20x, and 5 times 3 is 15. And then it's simply a matter of adding like terms, which we have lined up in nice columns. So we have x to the 4th, negative 4x cubed plus 4x cubed would be 0x cubed, so we don't have to include that. We have 3 minus 16 would be negative 13, plus 5 would be negative 8x squared. We have 12x and a negative 20x, so negative 8x, and then our positive 15. All right. Some special products. These should look familiar. We're just reviewing here. Special binomials. In this first example, we have a sum and we have a difference. When you FOIL those out, you'll remember that the middle term drops out, and we end up with just u squared minus v squared. If we take the square of a sum or a difference, we have to think of writing that out twice and FOILing it. So u plus v times u plus v. U times u is u squared. Outsides we get uv. Insides we get another uv. And last we get v squared. So when you combine like terms, you end up with this. U squared plus 2uv plus v squared. And the only difference with the next example is that there's a minus sign in front of the 2uv. The last two are patterns for cubing, either a sum or a difference. In this case, I want you to pay special attention to the patterns that you see. Just like in the squares, we squared the first and we squared the last to get these two pieces. Same thing with the cubes. We cube the first, we cube the last. And then you'll notice that in the squaring pattern, we have a 2. In the cubing pattern, we have 3's. And the only difference is that in this term, we have u squared times v, and in the third term here, we have u times v squared. If you memorize one, I would memorize that one, because the second one, this cubing of a difference, can just be thought of as u plus a negative v. All right, so if you know the plus pattern, you can do the difference pattern as well. Just two changes in sign here and here. All right, let's try a couple. The first one, we are multiplying 3x plus 8 times 3x plus 8, sorry, 3x minus 8. So we have a sum and difference. So our middle terms should drop out. We should be able to take the 3x squared, so 9x squared. Insides and outsides will cancel. And last gives us negative 64. All right, so that was following this first pattern right here. Question B, 5y minus 4 squared. You can follow the pattern for the square of a difference, or you can write it out twice. My hope is that you get used to this pattern so you don't have to write it out twice and FOIL it. We end up with 5y times 5y, 25y squared. Notice that insides and outsides both will give you a negative 20y. So since you have two of those, we just double it and we get negative 40y. And then the last term, we end up with a positive 16. All right, for question C, notice that there is a cube of a difference. So I'm going to think of this as 2x plus a negative 3y. Think of it that way, and then I don't have to worry about my signs. They'll just reappear where I need them to. All right, the pattern says take the first term and cube it. Our pattern says we're going to add 3 times u squared, the first term squared, times the second term. So in this case, our u is 2x and our v is negative 3y. Then we're going to add similar, a 3, the first term, 2x, and the second term, negative 3y squared. And then we add the second term, negative 3y, and we cube it. Now because I put this negative in with the 3, I can just focus on a plus sign, and you'll notice that all of my terms here have a positive symbol, and any negatives are going to show up where I need them when I do the multiplication. All right, sorry for that interruption. So 2x cubed will give us 8x cubed. Then we have 3 times 2x squared times negative 3y. Now we want to be careful there because we have to square first, which means this is going to turn into a 4x squared. And when we do this part, we have 3 times 4x squared times negative 3y. Doing all of that multiplication is going to give us negative 36. And then we have an x squared term, and we have a y term. Doing similar things with this next chunk, we have to do the squaring here first, so that's going to give us a 9y squared. Multiplying it to 2x and 3 gives us 54xy squared. And then our last term, we're taking negative 3y and cubing it, so we are going to end up with negative 27y cubed. All right. Okay, factoring polynomials using special products. This is just the reverse. Instead of multiplying them out, we're going to try to factor them back down. Factoring the polynomial is writing a polynomial as the product of two or more polynomial factors. In this appendix, factor polynomials to a lesser degree with integer coefficients. A prime polynomial is a polynomial that cannot be factored using integer coefficients. A polynomial is completely factored if it is written as a product of its prime factors. All right, so we're trying to factor it as far as we can go. First step, factor common factors from each term using the distributive property. In other words, undistribute them back out. The second step, recognize the expanded form of the 5 special binomial products. The difference of squares, sum and difference of squares and cubes pattern, that type of thing. Step 3, use factor pairs if it's not one of our 5 special ones. And step 4, if there are 4 terms, try the grouping method. All right, so example 4. We have 2x cubed plus 2x squared minus 6x. The first step here said, let's factor out common things. What's a common term? And in this case, we could take a 2 and an x and divide it out of every single piece, which leaves us with x squared plus x minus 3. All right, we then have a trinomial, x squared plus x minus 3. However, after you try factoring it, you'll realize that there are no factor pairs that work, so that is prime. Question B, u cubed v plus u v cubed. We can factor a u and a v out of each term. That leaves me a u squared plus a v squared. That is the sum of squares. We cannot factor that further. All right, example 5, factoring the difference of 2 squares. This one should look familiar from Algebra 2. We've got 25x squared minus 36. Both of them are perfect squares. There is no middle term, which means it dropped out. We are going to take that 25 and split it into 5x, 5x. We're going to take the negative 36 and split it into a positive and negative 6. Then we have one sum and one difference. Our middles would drop out and leave us with 25x squared minus 36. Question B, you'll notice, is a difference of squares, but this is a quantity that's being squared. So we have to take it as its whole quantity. So looking for the root of 4x squared, we would split that into 2x and 2x. Splitting up the y plus 3 quantity squared, we are going to need a y plus 3 in each one. And then remember, one has to be positive and one negative for our middle term to disappear. We can go ahead and distribute the negative in the second factor. So 2x plus y plus 3, all multiplied to 2x minus y minus 3. All right, a perfect square trinomial is the square of a binomial and has one of the 2 forms shown here. In this case, we have a positive here, we end up with a positive here, negative, end up with a negative here. All right, so the signs are matching. First example, we have 9x squared plus 6x plus 1. Notice that the first and last terms are perfect squares. In this case, we have that. That's a perfect square and that's a perfect square. If you think of their roots, the square root of 9x squared would be 3x. And the square root of 1 is 1. If you think of writing that out twice, to get a positive 1 here, we can have 2 positives or 2 negatives, but our middle number has to be positive. And when you FOIL, that's where that 6x comes from, the insides and outsides being combined. At this level of math, we would expect that you would simplify that to just be 3x plus 1 quantity squared. Okay? Same idea in question B. Both our first and last terms are perfect squares, so the first thing I would check to see is, can I write this as the quantity of something squared? 4x squared's root would be 2x. 9y squared's root would be 3y. To get a positive for the 9, I need 2 positives or 2 negatives. This tells me I need 2 negatives. So if I had 2 of those factors, again, thinking of it written out twice, insides and outsides would combine to give me this negative 12xy. All right, in the sum and difference of two cubes, notice the pattern of the signs. If you have the sum of two cubes, u is being cubed and v is being cubed, and we're adding them, your first factor will be a binomial that has the roots, u and v. The second is a trinomial. We have the first one, u being squared at the beginning, and the second, v being squared at the end. And then we simply have the product of the two in the middle, and our signs are opposite. So we keep the same sign here, but we keep opposite signs here. Last term is always positive. Okay, same pattern holds for a subtraction. We have the first one being just the roots of each of the original u cubed and v cubed, and then the second is a trinomial. We have the squares first and last, the product of the two in the middle, and again, same signs to start with, opposite signs here. All right, so let's try a couple. We have u cubed minus 64. We want to find the roots. So the cube root of u cubed is, the cube root of x cubed is just x. The cube root of 64 is 4. And the first sign here, minus, matches here. So we have the original binomial piece. Now we need the trinomial piece. Our first piece is the square of x. Our last piece is the square of the negative 4. Our middle piece is the product of the two, 4x, and it's the opposite sign that we started with. So if we have a minus here, we need a plus there. All right, example B, 8x cubed plus 27. Both are perfect cubes. The root of 8x cubed is 2x, and the root of 27 is 3. So that creates my binomial, and now I can build my trinomial from that. I square the first term, so 2x squared, 2x times 2x is 4x squared. I square the 3 and put it at the end, that's my 9. And I just multiply the 2x and the 3 to get 6x in the middle. And we need opposite signs, so a positive here means a negative here. All right, factoring trinomials. Factoring the trinomial ax squared plus bx plus c into a product of binomials with integer coefficients requires factoring the integers a and c. This is unfoiling. All right, so we look for factors of a to fill in these pieces. And then we look for factors of c to fill in those spots. All right, so factoring x squared plus 5x minus 14. X squared, the only way to break that apart is x times x. We have a couple ways to get a negative 14. All of those are options. We are looking for one that multiplies to give us this positive 5 in the middle, which would be this option. So we need an x minus a 2 and an x plus a 7. You guys have probably been factoring like this for years, so we'll go through this fairly quickly. Y squared, we would split into y and y. We need a factors of 30 that multiply, two numbers that multiply to be 30, but then add up to negative 11. So negative 5 and negative 6 would be our combination. All right, example 9. Factoring a trinomial where the leading coefficient does not equal 1. This requires a little more thought. So in this one, factors of 35, we have 1 and 35, or 5 and 7. Factors of negative 12, negative 1 and 12, or its opposite. Negative 2 and 6, or the opposite. Okay, and then negative 3 and 4, or the opposite. All right, then we need a combination of those numbers that gets us to a negative 1 in the middle. if we multiply using the 5x and the 7x option, trying to get that negative 1, if we have a negative 3 here and a positive 4 here, checking our insides and outsides. Insides gives us negative 21x, outside gives us positive 20. That would give us the negative 1x right in the middle. All right, go ahead and pause the video and try question B. All right, checking our options. For a 10, we can do 10 and 1, 5 and 2. For 12 to be positive, 1 and 12, 2 and 6, 3 and 4, or both of those could be negative, but since we're looking for a positive in the middle here, we'll stick with our positive options. Multiplying a 10 with numbers like 12, 6, even 4 here gets fairly large. So let's start with the 5 and 2 option. See if we can get that to work. We're trying to get to a 23. If we use this option and multiply the 4 and the 2 together, that would give us an 8, and multiplying the 5 and 3 gives us 15. That will add up to our 23. So we need the 3 to be multiplied to the 5, which means it has to be out here to get us our 15, and the 4 here to get us our 8. All right, if you are struggling at all with factoring, make sure you come in and check in with me and I'll see what I can do to help you out. The next two are still trinomials, but you'll notice they have both x's and y's. We're still going to look at it just like we factored the other trinomials, except we'll have a variable on the end as well as one at the beginning. So factors of 3x squared would need to be 3x and 1x. To factor a 2y squared at the end there, our only option is 2y and 1y. We just need to figure out where we're going to put them. If we put the 2y here and the 1y here, we get 1xy in the middle and 6xy's on the outside. So that will get us the 7. Now since the 7 has to be negative, having both negative options will get me the negative 7 here and still keep it positive there. All right, go ahead and pause the video and try question B. All right, checking our work. We have 6x squared. Our options are 6 and 1 or 3 and 2. I'm going to try the 3 and 2 first. I usually start with the smaller ones. To get a 10y squared, that is negative, I need a 10 and a 1, one of them being negative, or a 2 and a 5, again, one of them being negative. To get an 11 in the middle, if I multiply a 2 here, I get 4 in the inside, and 5 out here, I get 15. Since I want the 11 in the middle to be positive, I'm going to have my 15 positive and my 4 negative. All right, the last type of factoring that we are going to review is factor by grouping. This is used when you have 4 terms. It's, again, looking at that undistributing kind of idea, pulling out some common things. We break it into 2 parts. So what is common in the first 2? And in this case, we could take an x squared out of each one, and we would have left a 3x plus 1. Looking at what's common in the second 2 terms, negative 6x minus 2, we could factor a negative 2 out and have 3x plus 1. For the grouping method to work, what's left over, this piece, has to match. If it does, that's one of your factors. And the other factor comes from the 2 pieces that you've pulled out, x squared minus a 2. And you can double check that, you can FOIL that out and see that you get back to where we started. All right, question B. What is common in the first 2? In this case, we can take a 2a out. We would have c minus d left over. Knowing that we want c minus d left over here to match, we can look at this and say you can take a positive b out. So our common piece is one of our factors. and the two parts that we pulled out forms the other factor. All right, and the last topic that is reviewed in this appendix is the idea of function notation and substituting values other than just an x. All right, so we are given function f of x is 3x squared minus 2x plus 1. G of x is just the constant 2. P of x is the expression 5 minus 4x. And k of x is 2 minus x squared. Our first one they said is to evaluate f of negative 1, which simply means we're plugging a negative 1 in for all of the x's in function f. So right here. So we have 3 times negative 1 squared minus 2 times negative 1 plus 1. Simplifying, negative 1 squared is 1 times 3 is 3. Negative 2 times negative 1 is positive 2. And we end up with a total of 6. So f of negative 1 is just 6. Our second question says take g of 5 and square it. Now notice what I said there. We are taking g of 5 and we are squaring that. So if we look at our g function, g of anything is a constant 2. It doesn't matter if we're putting a 5 in, a 10, a negative 50 million. It's just a 2. So this is going to be just a 2 getting squared, which would be 4. Question C says take function k, and in place of this x, we are going to substitute this whole quantity, 2x minus 1. So we end up with 2 minus this quantity squared. Our quantity again is 2x minus 1. We need to write that out twice and FOIL it, or think of our pattern. We've got 2 minus 2x gets squared. All right, 2x gets squared to be 4x squared. We multiply the two together and double it. So 2x times negative 1 is negative 2 doubled is negative 4x. And we square the negative 1 or positive 1. Now notice that this minus sign here had to apply to all the things that got squared in there. So we are going to distribute that in. We are going to end up with 2 minus 4x squared plus 4x minus 1. And then we could combine the 2 and the negative 1 to be negative 4x squared plus 4x plus 1. All right, our fourth example here, D, still working with that same function. We have a different expression to plug in, 4 minus x. Why don't you pause the video and try that one. All right, checking our work. We have 2 minus a quantity squared, and this time our quantity is 4 minus x. Squaring that, 4 squared is 16. Multiplying the 4 and x together and doubling it gives us negative 8x, and squaring the negative x is x squared. Distributing our negative, we have negative 16 plus 8x minus x squared, and combining like terms and putting this in standard form, negative x squared plus 8x minus 14. All right, f of x. We are taking 3 times x squared minus 2 times x plus 1. And we are dumping this quantity in. So x plus 2 goes in for all of our x's. Again, we need to square it in this first term. X plus 2 squared is x squared plus 4x plus 4. Go ahead and write it out twice and FOIL it if you need to have that help. Our second piece, we're taking negative 2 times x and negative 2 times 2. And then we have a plus 1 at the end. Next step would be to distribute the 3. So 3x squared plus 12x plus 12, and then bringing down our other terms. And combining like terms, we would have 3x squared We have 12x minus 2x, or 10x. We have 12 minus 4 would be 8, plus 1 would be 9. All right, question F. Same function. 3 times something squared minus 2 times something plus 1. This time, though, we are plugging in an expression x plus h. We don't have any numbers, but we're going to do the same process we just did. All right, so squaring x plus h. We square the x, we multiply them and double it, so 2xh, and we square the h. Distributing the 3, 3x squared plus 6xh plus 3h squared. Our second term, we must distribute the negative 2, so we have negative 2x minus 2h, and then we have the plus 1 at the end. Combining like terms, we have 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 1. What do you notice? We didn't have any like terms to combine in that one. All right, our last question says take f of x plus h, what we just did, this whole thing, and subtract the original function f of x, and then divide it all by h. So we are going to, this is question G, we're going to start out with f of x plus h. Okay, and then we are going to subtract the original function. Our original function for f was 3x squared minus 2x plus 1. We are going to subtract all that. 3x squared minus 2x plus 1, subtracting all those pieces, and then dividing the whole thing by h. Whoops, a little too far there. All right, let's go ahead and distribute this negative sign. We have 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 1 minus 3x squared plus 2x minus 1, all divided by h. All right, there are some terms that will drop out. For example, we have 3x squared, and we're subtracting 3x squared. That's 0. We have a negative 2x and a positive 2x. That's 0. And we have a 1 and a negative 1. That's 0. So this simplifies down to 6xh plus 3h squared minus 2h. And you'll notice that all of those terms that we have left have an h in them. So when we divide that h out, we have 6x plus 3h minus 2. All right, so for section A.2, we did all the notes together in one video. However, assignments probably will take a little more than a single day. We are doing 1 through 7 odd, 9 through 39 multiples of 3, so 9, 12, 15, etc. 41 to 44, 45 to 55 odd, 56, 60 to 66 multiples of 3, 69 to 73 odd, 75 to 90, again multiples of 3.